Welcome to 21st lecture in second chapter of this comprehensive course on machine learning, data science and artificial intelligence. Now, here we want to do something. Previous lecture was about this palindrome. Similarly with strings, there is one another thing called anagrams of string. Okay, so we want to do that. But first I will have to explain what are anagrams. So here, suppose I have a string ABC. Now what are its anagrams? Then anagrams are the possible strings which are available by rearranging characters of the given string. So the given string is ABC, but I can write ACB, I can write BAC, I can write BCA, I can write CAB, and I can write CBA. So that means from given string ABC, I can obtain 5 more, or total including the given string 6 anagrams are possible using these 3 characters A, B, and C. Now how to calculate them? Then that is calculated by 3 permutations 1. This is P is for permutations, and 3 permutations 1 is found by 3 factorial. This number here is called factorial. This one, this symbol is called factorial. What is this factorial? That is 3 multiplied by 3 minus 1 multiplied by 3 minus 2 multiplied by so on. You have to go on doing, starting with first number and multiplied by that number minus 1, that number minus 2, and you have to go on extending that series until you get 1. Now here you get 1 very quickly because this first number is 3. Then the next number will be 3 minus 1, that is 2. And next number is 3 minus 2, that is 1. As soon as you get 1 in that series, you have to stop. So how many factorial, how many permutations are possible? Then 3 2s are 6. So that is why here you are getting 6 possible anagrams. Now we want to develop a script which gives anagrams of any given string, not only ABC but any given string. Okay. So for that you can write for iter tools, from iter tools import permutations. So these iter tools are by default available with Python, and iter tools, so they are a particular set of libraries, and permutations, as we have said, this is what is called the way of finding the permutations. So that permutations library will help us quickly calculate permutation. Then I define a simple function, get anagram. That function will take one string as an parameter and it will use that string here for p in permutation. For p in permutation, join p. Okay. So and this we have now done. So we know that nothing is specified means between the consecutive strings there will be a space bar. Okay. So what this simple function does, whatever string you pass to it, it finds all possible permutations of it. For example, if I pass ABC, then it will find all these possible permutations, ABC, ACB, BSc, BCA, CAB, and CBA, and then it will join them with keeping a space between them. You can keep a comma if you want, then you have to provide it here. So let us check our string. So first, this will print original string, okay, and this much part, because here we are just defining the function, we have not yet called the function. So here we are calling that function with this original string ABC, okay, and then whatever result that will give, what it will give? It will give all possible permutations with this a list of all possible permutations, because join always returns this list, okay, and that list result given by that function, that is stored here in the anagrams. So these anagrams is a new variable which will be stored, a list variable, and then we are trying to print that anagrams. Okay, so let me first execute this. So that original string is printed ABC. Now that we all know, but then here now execute this, and you can see that all possible combination ABC, ACB, and all are now printed. Now you can understand the importance of this. Here original string I have hard coded, but instead of that you can always put a command like this, that input, and then in that you can provide enter a string whose anagrams you want to find. Okay, so then in that case what will happen is, whenever this line of code will be executed, then in that case, and that line then you will put somewhere here, so that that variable will be printed, and the original string also you will print here, so that the input taking and the logic of your code, that these two remain separate. Okay, so this part will take input and this part will print just for the check what user has given as input. Let me again try to execute, and oh, quotes missing. Whenever quotes are missing, you can see that this unterminated string literal will be seen. So always remember that that just means quotes are missing. Okay, so enter a string. So I am just writing that same ABC, and I press enter. So original string is ABC. Thereafter that string is saved in this string variable. Now you are calling your function, and that string is passed to this function. That function find all permutations of that string S, and it joins them, okay, and returns. Returned value is stored in this variable, which is a list, and then you are printing that list. This also can be done. So now I can actually, that means find anagram of any string. So instead of ABC, now I can write, say, PQRS. Now for 4 it will be 4 factorial. So that will be 4 multiplied by 3 multiplied by 2 multiplied by 1. So 4 3s are 12, 2s are 24 different anagrams will be there. Okay. Oh, sorry. So these are 24 different anagrams. So you should understand that this will make a very handy script, because what are all possible combinations from a given string that you can readily calculate. Then there is another which we want to do is, I think this we have already done, fine. This also we have already done. Concatenation also done. Leap year also I think done. Yes, leap year was also done. Now what we have to do is, one is this script to determine zodiac sign. So it looks a long script, but it is actually very, very easy. First, helpful information is also given, because everybody may not be this zodiac inclined person. So a person who is born between this limit, 21 March to April 19 of any year, he is called Aries. A person who is born between this month and date and this, that he is called Taurus zodiac sign, and so on. So it is clear that from user one you will have to take as input, you will have to take as input month, and you will have to take as input date. That enter your month of birth and enter your date of birth. Okay. Thereafter it is easy. This is that function to which you will supply the day and the month. Day here means date, remember, and month as argument, and you will get the zodiac sign. This looks a long code, but it is just a simple if-else statement, that if month is 3 and day greater than 21, or month is 4 and day less than or equal to 19, Aries. So actually this just means in words that if a person is born on or after 21st of March, and or if he is born in before, on or before 19th of April, then in that case his star sign is Aries. Similarly, if he is born on or after 28th of April, and or he is born in this on or before 20th of this 5th month, May, then in that case he is Taurus, and so on. Okay. Remember, we are putting this or. I am speaking and, because I am saying that there are both these are allowed, but both these are allowed means either he is born in the month of March and the day is greater than or equal to this, or he is born in the month of April and the day is less than or equal to this. Because for each zodiac sign, 2 possible months are there. March and April decide Aries, April and May decide Taurus, May and June. So people born in May also can be Gemini, and or people born in June also can be Gemini. That's why that or. Now otherwise this is easy function, and this part is a separate part. Here we don't do anything, we just take input from the user, and we pass that input as the argument, and that input will be, those arguments will be supplied to these parameters. Okay. So I am taking n is equal to 5, so that means I want to take 5 attempts and prompt user for date and date. So I am asking first day. Now day here means date, so it should be stored as integer, because I want to compare it, or equals with integer. Okay. So it should be casted as integer. And month also, I am not asking enter April or something. I am just asking very clearly that please enter like this between 1 to 12. Okay. So it will also be casted as integer. Date is stored in this variable, birthday. Month is stored in this variable. Then we are calling that function which we have defined above, get zodiac sign, this function, and we are supplying the whatever user has entered as date and month. And then obviously whatever the function will return, that will be the sign. So we are storing the return value in this variable, and then we are printing that variable. So it is very, very easy to execute this, and each time we print, we decrement that n by 1. So after first attempt n will become 4, after second attempt n will become 3, so that endless it will not go on going on, because zodiac signs are usually quite magnetic and people will go on doing. Okay. So here I am entering some random date, so 15, and some random month, say 6. So Gemini. Now let me check 15th of June. So 15th of June satisfies this condition. It is between May 21 and June 20. Okay. So then I again enter some other number, maybe 15, or why only or less 15, say 26, and I enter the month as 2. So in that case, Piscean. Okay, that person is Piscean. Again, I can see here the condition for Pisces is after February 19 and before March 20. So this is February 26, and therefore is Piscean. Okay, I can go on doing, but this is a very simple script, so I don't want to go on doing it again and again. Okay. Then let's go to next question. Script to check if a number is Fibonacci number. And such hint will be given to you. If it is a programming task, then you are not expected to know mathematics. Some very strict organizations do not give them. You may be asked to remember what are Fibonacci numbers. But normally, I think to my mind, they should be given. Okay. So then, what are Fibonacci numbers? So Fibonacci numbers are those when one or both of 5 into number square plus 4 and 5 into number square minus 4 is a square, perfect square. What is the meaning? Let us see here. For example, here this is a list of Fibonacci number. So let me take that number 2. So n is equal to 2. Now if I want to find if it is Fibonacci or not, so then I can write 5 into n square plus 4. So 2 square plus 4. So 5 4s are 20 plus 4, 24. But 24 is at least not a perfect square. So this is at least not perfect square. Then I have to try another. Okay. So 5 into n square minus 1. So 5 into 2 square minus 1. Again 4 5 are 20 minus 4. Minus 4, sorry. So 20 minus 4. So answer is 16. And that means it can be expressed as a perfect square. Then the definition says that if a number is n and you can express 5n square plus 4 or 5n square minus 4 and you find that at least one of them is perfect square, then that number is a Fibonacci number. A very simple definition is there. And all these numbers you can try, find their square, multiply by 5 and then add 4 or subtract 4. Then at least one of the two answers obtained, they will be a perfect square. Okay. Now this is that script. So here what we are doing, that is the whole script is divided into 3 parts. This part is very simple. It just takes the input from the user that enter the number which you want to check if it is a Fibonacci number or not. Okay. And of course here I want to treat it as a number only. I want to square it and all that. So this is that int casting it is required. So this will be stored as an integer in this num variable. Then I just use that num variable, whatever user has entered, to call my function is Fibonacci. So I am calling is Fibonacci. So if is Fibonacci means what? If is Fibonacci equals true. That means if when I call this function with this argument, that is the value entered by user, then if the function returns me true, then function is that the number is a Fibonacci number. If the function is Fibonacci returns false, then that is not Fibonacci number. So that means I have to design somehow is Fibonacci function so that it finds 5n square plus 4 and 5n square minus 4, and then it checks if that is a perfect square or not. So this is my is Fibonacci function. So it is taking that number as an argument. So number is passed as an argument n, and then we are finding 5 into n plus 4, and this is 5 into n minus 4. But we are, rather than calculating manually that if this is perfect square or not, we are using yet another function. So whatever values are obtained for 5n square plus 4 and 5n square minus 4 by this function, it is passing that values to this another function is perfect square, and that is this function. So such functions is perfect square which are used by one function to complete its full functionality, they are called helper function, because actually this function is what? It is Fibonacci. So its job is not just to find this 5n square plus 4 and 5n square minus 4. Its job is to decide if the number n is Fibonacci or not. But it does only half of the job. Find 5n square plus 4 and 5n square minus 4, and then it takes the help of this function, okay, to do the remaining half of the job. Okay. So obviously what that remaining half of the job will be doing, that helper function would be doing, it will check if these numbers which are passed to it, they are perfect square or not. Okay. So then this is another function is perfect square, and it is taking some argument, say x. What will be x? One by one, that function is being called 2 times here. So first x will become 5n square plus 4, and next time x will become 5n square minus 4. Okay. And then we are finding the square root, and then we are printing this s. Okay. And then we are printing this equivalence. Now here I want to show some important thing. That's why I have added these 2 print statements. Otherwise these print statements are not required. But I just want to show something that how this code actually works. And then return comparison. Okay. So this code uses and intelligently uses one important property, that when you cast a number, square root etc. will always be a floating point number mostly. But when you cast it to integer, then it will downgrade to only the integer portion, and it will ignore all these fractional portions. Okay. Now why does this matter? That I am going to explain. At present, don't look at this 13 point something and that. But first let us execute the script and enter some number. Okay, there is pending input. Why that pending input is seen? Because here there were 5 provision for 5 zodiac sign, and I have only used 2. So this kind of pending input problem will arise. If this arises in your case, then you will go to this tab kernel and you will do this thing, restart kernel. Okay, once you restart kernel, thereafter you can also do restart kernel and clear all outputs, or here clear cell output. Now I am coming back to, now my script will not get that pending input. Yes. Now enter a number to check if it is a Fibonacci number or not. So if I first enter simple number 2, so if I enter number 2, how this function will work? First it will check if number is greater than 0. Fibonacci are not defined for negative numbers. If it is greater than 0, then it will enter this while loop, and it will just call this function is Fibonacci and pass 2 as an argument. So 2 is passed here as a parameter. Now this function does not do much. It just finds 5 into n square plus 4 and 5 into n square minus 4. For 2 I have already shown 5 into 2 square plus 4 will be 24 and 5 into 2 square minus 4 will be 16. So it one by one passes those two. Okay. So is perfect square function will be called, that helper function will be called, and that function will take this value as input, 24 first time and 16 other time. So here 24 will go, then you are finding its square root, okay, and you are casting that square root down to integer, and then you are printing that value, okay. Now then this checks if again when you square that square root, that becomes equal to the original value or not. Now try to think, if original number is say 24, then when you find its square root, let me open a calculator so that I can express the things. So 24, if I write and it's the square root I find, it is this number, okay. So if I don't cast it as integer, there will be problem, because when I square it again, then it will not be 16 or it will not be 24, sorry. So multiplied, or I find x square, okay. So yeah, here it is exact 24, but when I cast it, so again I find square root, so that this was the number. Now when I cast it and take 4 and then find square of 4 only, then that will be only 16. So that means after casting, even if I pass the 24 here, from where 24 is coming? 24 is coming from 5 into 2 square plus 4, okay. So that 24, I passed the 24 here, I found the square root. Square root was at 4.89 something, but I casted it as an integer. So that's why now only 4 is there. Now I am again squaring it. So 4 4s are 16, and I am trying to compare it with original number which was passed, but that was 24. So what do you expect for this condition? It will evaluate as false. 16 equals 24. No, so this will return false. Okay, and in that case, this return of that value, that will be false. Where that return is going? Return is going here, and from there where the return is going? Return is going here. So false. If true is entered, then number is a Fibonacci number. But if false is entered, then number is not a Fibonacci number. Okay, so for 24. If I consider only one possibility, it is not a Fibonacci number. What I am saying is that suppose I don't cast it, or rather, okay, but here I have to consider this 5n square minus 4 also, because that value when I pass, that is I pass this 16 to my helper function. So 16 I am passing here. So you can see that there is 16, and here there is the square root of that 16, and that would be exact 4. So whether you cast or don't cast does not make any difference. So we are printing that number. So it is 4. Then we are printing the square of that and matching of with original number. So 4 square is 16, and original number which was passed was also 16. When I pass this, then okay. So then in that case, what this return for s multiplied by s equals x will return. This condition will evaluate to true. So in that case, number would be Fibonacci number. So this 2 is a Fibonacci number because 5 into 2 square plus 4 is 24. That will not satisfy this condition. But 5 into 2 square minus 4, that is 16, and that will satisfy this condition. So this will return as true. Let us check. So it gives their comparison is the this false is what? That is the comparison of this. Okay. Print. So first this 4, that is the printing of this s. Then print s square equals x. So first time it is printing false because at that time 5 into 2 square plus 4 went in, and that 24 went in, and 24 its square root was 4.89, and when you cast it, it became 4, and then it here square became 16, but 16 when compared with 24 gave false. So first option gave false. Next time you pass the 5 n square minus 4, that was 16. 16 was passed here. You find square root and cast it, so it gives 4. Now 4 into 4 you again do, so that is again 16, and that time it evaluates as true. So that true value, this evaluates as true for 5n square minus 4. Okay, so then in that case that true will be returned, and the number is Fibonacci number, because the condition is very simple. Either 5n square plus 4 should return true, or 5n square minus 4 should return true. At least one of them should return true. So this OR takes care that if at least one of them returns true, then this will return as true. Okay, fine. So that too is a Fibonacci number. The usefulness of these also can be seen if I want to check say this type of number 89. Now obviously if I cannot show you on a paper like this 5 into 89 square plus 4 and 5 into 89 square minus 4 because that will be lengthy calculation. But this script can easily do it, that 89 is also Fibonacci number. Okay. But now let me enter some number, say 6. Then it says that 6 is not a Fibonacci number. Okay, 6 is not a Fibonacci number because in this list, this is the list of Fibonacci number which I have given for your convenience. So 6 is not present. Why? What happens when you give this 6 here? So 5 into 6 square plus 4. 6 square is 36. 36 5 is 180. 184 will go. Now 184 goes here. Then here its square root will be obtained. Let me open that calculator and let us check what will be the square root of 184. So 184, then it's the square root. Now this is its square root, 13.56 this. So actually S should be 13 point this. Okay, then when you square it again, it will again become the value 184 which I am passing to it. Okay, so if I do this square again, then it becomes 184. But my problem, or not problem, but it is a functionality in my script that I am casting integer. So that means this would be not saved as this number, but only integer part of that will be saved. 13 will be saved. But then what will happen when I square it? It will become 169, while my original number was 184. So after again resquaring and trying with the x, comparing with 184, 169 equals 184? No. So this will return false. And other choice, 5n square minus 4. Now that would be 5 into 6 square, so that would be 180. 180 minus 4, that would be 176. Okay, so let us find its square root. 176 will go here. Then here you are finding its square root. Okay, so that is 13.266 this. Okay, and as a result what will happen, if you keep it as it is, if you don't cast it, then when you again square it, it will again give 176. For example, if I just press the square button, it gives 176. But then the whole logic will say, I want to check if Fibonacci is there or not. That means I want to check that square rooting and then squaring again gives same number or not. That means I want to check that if 5n square minus 4 or 5n square plus 4 are perfect square or not. That is not being checked here. Okay, so here what you can do is cast by integer. If you don't cast it and try to print it, then what happens? If you cast it, then the numbers are here. So the 6 is not Fibonacci number. Okay. Now if you don't cast it, let me first clear all old output and then execute this script again. Restart of kernel, restart kernel and clear all output. Okay, and then execute, and then I pass 6. Okay, but this time suppose I want to I don't put this math square root x and then pass same number 6. Then my script will fail to detect that it is not a Fibonacci number. It will say that it is a Fibonacci number. Why? Because if I don't cast it, then print as, if you see, then it will print this. It will take internally stored this, and when I square it again, then it will match with, though it is not a perfect square, it will match with the original number, and therefore that means that 176 or whatever numbers were there, these are not perfect square, 176 or 184, but it will match with the original number here, and therefore this whole logic will fail. So this casting to integer, that is the key point in this script. Try to think about it. If you have any issue, then you can ask the query. I will again restart the kernel and stop thereafter this lecture, because whenever such inputs are pending, then you must restart the kernel, otherwise the next script will not work, because there is a pending input in the previous script, so it will not work. Okay, thank you.